Well, today I'm going to talk about AP questions. The PPT is made by James Bao and Jimmy Yu. Although it is called AP questions, I believe it is very simple if we listen carefully in class. The first question, it gives us a curve in the function, and he wants us to show the dy dx equal to y over 2y minus x. When we see dy dx, we must think about to have the derivative of the function. So y squared will become 2y times dy dx, and the 2 plus xy will become this, because here we need to use product rule, and simplify this by move this to the left, and we can get dy dx is equal to y over 2y minus x. B. Find all points x, y on the curve where the line tangent to the curve has slope 1 over 2. The slope is 1 over 2 means the dy dx will equal to 1 over 2 because they are the same things. So 1 over 2 will equal to y over 2y minus x. Simplify it. We can get x equal to 0 and y squared equal to 2. And y will equal to positive negative square root 2. So the final coordination of the question will become 0, comma square root of 2 and 0, comma negative square root of 2. See? Shows that there are no points x, y on the curve where the line tangent to the curve is horizontal. The line tangent to the curve is horizontal, which means the slope is 0. So 0 will equal to y over 2y minus x. So we can see that this could happen only at y equal to 0. Y equal to 0, the function will be 0. But y cannot equal to 0 because 0 squared are not equal to 2 plus x when x equal to 0. D. Let x, y be the functions of time t that are related by the equations at t equal to 5, and the value of y is 3, and the dy dx equal to 6. The question gives us lots of values, including the derivative, which is 6. When we see that, we need to think about that we need to have the derivative of the original function. And while we plug 3 and 5 into the original function, we can get that 3 squared, which is y squared, equal to 2 plus 3x, because y equal to 3, equal to 9. And we can calculate the x, which is 7 over 3. And when we have x, we can use all of the values here to calculate this one. So we can finally get dx dt is equal to 22 over 3. The second question, it also gives us a function of a curve, and it shows dy dx is equal to 3y minus 2x over 8y minus 3x. We need to pay attention that here is a product rule, and others are very simple. So x squared will become 2x, 4y squared become 8y times dy dx, and this one become here. And by simplify it, we can get dy dx is equal to 3y minus 2x over 8y minus 3x. B. It gives us x coordinate is 3, and the line tangent to the curve at P is horizontal. Yeah, it happens the second time. So the slope is 0. 0 equals to 3y minus 2x over 8y minus 3x. Simplify it. We can get 2x equal to 3y. And we know the value of x, so we can get y equals to 2. So the coordination is 3, 2. C. Find the second derivative of the point P in part B. So we need to find the derivative of 3y minus 2x over 8y minus 3x. It is very easy when we use the chain rule or the quotient rule. We make the square of that one, and using the quotient rule, we can finally get dy. The second derivative of dy dx is negative 2 over 7. Because we know the value of x and y, so while we have this, we can plug them into here and get the value. Question 3. When we see the questions like this, it is very long and hard to understand. So we must to get the main points of the question. So the question said that the radius is 5, and the rate of change of the volume is 5 pi square root h. So when we see the rate of change, it means the derivative. When we have a derivative, we need to have another derivative. And how can we get that? Using this one. So dv dt will equal to pi r squared dh dt plus h 2 pi r dr dt. And we know the radius is 5, and the dr dt is 5 pi square root of h. So plug them into this. We can finally get dh dt, which is equal to negative square root of h over 5. Next question. Consider the equation. This. Find the second derivative. It means we need to find the derivative of x squared minus 1 over y, 1 over 2y. It is very simple. 2x will become x squared, or x squared will become 2x, and 1 over 2y will become dy dx 1 over 2. And pay attention, because the original question gives us the value of dy dx. So here, we need to put the x squared minus 1 over 2y here. So the function will become the second derivative of dy dx equal to 2x minus 1 over 2 x squared minus 1 over 2y. Simplify it, we can get the final answer. Next question. It gives us the original function, and the question gives us the height of the liquid, h equal to 3, and the derivative of radius is equal to negative 1 over 5. Because it said decreasing, it's the rate of 1 over 5. Decreasing means the derivative is negative. Increasing means the derivative is positive. So we also need to have the derivative of the original function. So we can get dr dt equal to 1 over 10 h dh dt. And we know h, we know dr dt. So we can calculate the dh dt, which is negative 2 over 3. Next question. When the height of a calendar is 12, this is the height. Radius is 4. And the circumference is increasing at a rate of pi over 4, which means the derivative of the circumference is positive pi over 4. However, the question needs us to calculate the volume changing, which means the derivative of the volume. So first of all, we need to use the value, the question given, to calculate the dr dt, because dr dt is the only one we can calculate calculated by the values question given. And here is five choice of the answer we can choose. By using c equal to 2 pi r, we can get dc dt is equal to 2 pi dr dt. And we know the dc dt, so dr dt equal to 1 over 8. By using dh dt equal to 4 dr dt, we can have the dh dt, which is 1 over 2. And then we know that one, we can calculate the final answer by using the equation. Derivative both sides, we can get dv dt is equal to pi r squared dh dt plus h 2 pi r dr dt. And we know dr dt, we know dh dt. And we know the height and the radius. So plug all of them into the function. We can get the final answer. dv dt is equal to 20 pi. Next question. Find the dy dx if 3xy equal to 4x plus y squared. It is very easy. We just need to find the derivative. Here we need to use product rule. And here we pay attention to add one more dy dx. So the final answer will become dy dx is equal to 3y minus 4 over 2y minus 3x. Easy. And the last question, the radius of the circle. So here shows the derivative of the radius is negative 0.1. In terms of the circumference c, what is the rate of change of the area of the circle? So we need to find the derivative of the area by using the function. We can get dA dt is equal to 2 pi r dr dt, dr over dt. And we know dr dt, dr over dt. So plug it into here. We can finally get dA dt equal to 2 pi r times negative 0.1. And we know that c is equal to 2 pi r. So dA dt is equal to c times negative 0.1. That's all. Thanks.